Hi and welcome. Today I want to talk about a bit about the new C# 6.0 features that Microsoft brought us, together with the Rustling compiler and the .NET Framework 4.5.1 and point 2 and 4.6, and where these features can be used productively, where one should be careful with them. I just want to give you a simple overview of what they have to offer. All of this can be read about in the specification. The 6.0 specification is not yet released in written form, but most of them is already available in the document for the 5.0 version, which can be found on this link. All links to this presentation and the sample codes I'm going to show you will be in the description box of this video. Okay, let's get into it. The first thing I want to talk about is code readability. In today's day and age, it's not about writing the most safe spacing code you can write. That may have been an issue 30 years ago when disk space was very rare, when you had to avoid long names at any cost. In today's day and age, this is not true anymore. Uh, Especially in .NET, don't try to be more clever than the compiler. Of course, you have to look in regards to performance, how your code is performing, but that should only concern that you do not call methods unnecessarily and evaluate results over and over and over again. For example, if you do loops over lists more than one, even if that it's not necessary. That's the kind of thing you should be looking for. But don't try to beat the compiler. It's not working in this day and age. The same is true for variable names. Use speaking names. Your code should not be optimized for the compiler. Your code should be optimized for the next person who has to read it, for the next person who has to debug it. This is the goal these days. Let me show you a very old sample code of mine. Back then, I just tried to understand how the checksum of the International Standard Book Number, the ISBN, was working. So I just tinkered a bit with the description that was back then. I think it was already on Wikipedia, and I implemented the sample code. And back then, I just wrote the code down in the same manner as the description of the checksum calculation was made on the wiki page. And the problem is the code looks like it. As you can see here, what this part of the code does, it takes an ISBN and makes an European article number, the EAN, out of it, also known as the ISBN 13. You have a for loop with two nondescript integer variables that are counted up. You have a nondescript endpoint. This code is not very readable for the next one who has to understand what is actually happening in this part of the code. So you should avoid I, J, K, L, and M for loops. Just name them properly. I've updated this program to a more modern version, where I show you I've deliberately left some stuff in to show you this. Basically what I did is I inserted a proper interface so I can convert from EAN to ISBN, and I can convert from ISBN to EAN. The for loop has now proper names. I have now a left index, a right index, the lower bounds. Now all these variables have proper names, so it's clear what their purpose actually is. And for example, if I open the I converter, um, back in the day, it was usual to take a method, take the return, and immediately put it into another method. But this kind of code is not very good readable. You don't really know what's happening here. You have no insight in the return values of these methods. If you want to debug this, you have to go into the calculate method, put a breakpoint there. You have to go into the assemble method, put a breakpoint there, or you go to the point where the convert method was called. But as this is an interface, there could be many different outputs coming out here. So this one-line programming is not really comfortable to debug, to read, and a few more variables make it much easier to read and to debug because you have more than one line. And as I said, don't try to beat the compiler. If the compiler considers these variables to be pointless, he will optimize them out. That's not your job. Your job is to write readable code. And the same is true for all the features I'm going to show you now, because it's easy to see these features and think, yeah, that's what I want to use. That's the next big thing. Be careful that your code remains readable, because the old saying is, if you only have a hammer, everything starts to looking like a nail, even if it's not a nail. And that's just something we as software developers who want to develop clean code, who want to develop good code, should be aware of. Okay, but now get into the actual stuff. These is a standard slide Microsoft is providing with the features and enhancements that C# 6.0 is coming with. I'm going to present you the features with the black box around them. If there's a dotted box, I have examples of that in my code, but this will more a drive-by explanation. For example, the auto property initializer or the using static. That will be more drive-by than actual explanation, but the black box features are the ones I'm going to actually explain to you how to use them, how they work, and what their use is. Okay, the first thing I want to talk about is string interpolation. String interpolation is a new way to format strings and insert certain dynamic objects into a section of the otherwise static string. The same can be done with string format, but string format has the problem that if you have a string with already more than one replacement element, and you suddenly need to insert a third dynamic parameter, you either have to renumber the placeholders within the actual text, or you have a different order within the text and then in the replacement function behind the actual text. So now in .NET there are three kinds of strings. The first one is the regular string, just denoted by quotation marks. The second one is the so-called verbatim string. It starts with an at before the actual quotation marks. And the third one is the interpolated string, about which we are going to talk now. And I'm going to show you the example. So basically what I did here, I enhanced the zoom for the text so you can read it. I wanted to show you basically how the formatting is done. You can use the plain old text, you can use the verbatim string with the at in front, you can use the interpolated string with the dollar in front, and you can create a verbatim interpolated string by using the dollar and the at in the front. The verbatim string, as seen here, is good for when you don't need escaping, when you don't need escape signs in your code. The backslash in a normal string will always be an escape sign. If you want to use an actual backslash, you have to use backslash backslash. If you want to write backslash t to insert a tabulator, or the other way around, you don't want to use a tabulator and just write backslash t, you can use the verbatim string. Any escaping is then ignored, and that's why the verbatim string is so good for example path names, because under Windows and path you have a lot of backspaces, backslashes and backslashes, and yeah, with the verbatim string you can just ignore that. Then we're going to the interpolated examples. Let the code run. For example, the string types is just write line, and as you can see here, it's saying only write line, but in actuality it's console.writeLine, because I'm using the using static. The using static means basically you can import a class that has static methods like math or console, and if you use such a using here, you don't need to denote the class anymore. You can just call readline, but readline is console.readline. WriteLine is console.writeLine. It's not a method in the actual program class. I'm honestly not sure what this feature is really good for. Maybe if you have a class that works a lot with math and you just want to avoid typing math all the time. But other than that, I don't see an actual practical purpose for this new keyword, especially if it because it's using the using keyword again. So we have now three different types of usings in C#. We have the using namespace, we have the using static, and of course, sorry, we have the using for the idisposable variables. So this WriteLine is just outputting these strings without any replacement whatsoever. It's just to show you the syntax in front of it. Now we have the verbatim examples where you can, in the verbatim string, leave out any character escaping. And of course the output is absolutely identical in the end, as it should be. And now we come to the actual string interpolation. I've made up an example where for example, I first had the last name, and then later I decided to add the first name as well, and the first name was supposed to become before the last name. So I now have a different order of parameters here, where first the last name, then the first name, but the output shows me the first name first and the last name second. And that kind of problem I simply don't have in the interpolated string, because in the interpolated string, which starts with a $, the moment you open the curly braces, you return to the normal code. So in this segment, you can use anything that is normal code and produces an output of type object or type string. And then you close the curly braces, and immediately, without the uses of any quotation mark, continue writing your text And here we have another one, and in the end you close the quotation mark and you be done with it. And the output is of course as expected. Both times DJ Döner, except that in this formatting you can actually on first look see what's supposed to be happening, while if you have more of them and more plain text between them, it could get a bit confusing. Of course, um, formatting also works. I've just used two numbers, one 5 cents under 10,000 and one a 0, and decided to format them all the same with an divider at 1,000 and optional numbers before the first number. So price and freebie are formatted identically, but the result is different because freebie is 0 and doesn't have any leading numbers, and the big price is coming out exactly as I wanted it to, except as you can see here, it's German notation, so you have the dot between the 1,000 marks and the comma for the decimal separator, but in your case it will be the other way around. And the interpolated string does exactly the same, so you can use a variable, then you use the colon and do the same formatting as you would do with string format. So now we have a slightly more difficult problem. If you get the formatting not hard-coded like I did here, but you have an actual variable that stores the the formatting, then of course you can do a bit of string concatenation in the string format. You can call the toString method that already formats this price according to this format rule and then inserts it into the string format. And that's how you have to use it if you want to have a dynamic formatting in the interpolated string as well. You cannot use the curly braces and the interpolation string and somehow magically insert the format in some way. You have then to use the toString method with the formatting, and then it's inserted into the regular interpolated string. There are always limits to what you can do with one format or the other. And now we have one last example. I've simply created a path with the C drive and the Windows directory and have used all four different versions to create this one output, which then looks identical in all four outputs. And as you can see, the interpolated verbatim string suppresses character escaping, so you only need one backslash, but you can also insert the drive and the path at the appropriate locations. And if you look at this whole thing with a reflector, so you can we can actually look what the code looks like. Let me zoom that out a bit. As you can see, if possible, in this case, I had to reverse the order of the strings. So string 1 comes before 0. The code is still the old string format. But if you compare this example, the second one, where I inserted the numbers, that was this example. Now they come in exactly the same order as they're supposed to be, we use here string format and here the interpolated string. But if I look at the disassembled code, .NET already changed both of them to the new interpolated format. So basically, it changed the code internally to what it deems best, and you don't see it during your debugging session. That's what I meant with don't try to beat the compiler. It just shows it will do its own thing anyway. And here below the same, here it concats the strings, and then it does twice the interpolation, even though I used string format here, but for him that's the same as string interpolation, so it replaced it during compile time. Yeah, that's about string interpolation. The next thing I want to talk about is expression-bodied functions. Expression-bodied functions are basically lambda expressions. They are shorthand programming for better unreadability, which means it's intended for methods and getter properties that have an extremely short return value, where it's very clear what's supposed to be returned and what's the result of the method. It's like every lambda expression, it's very bare. It has an implicit return value. There's no explicit return in this case. You cannot even use an explicit return, unlike lambda functions, because that would defeat the purpose of the expression-bodied function. And yeah, let me show you how that works. I've prepared an example, like a good TV cook. I designed an interface. The code doesn't actually do anything intelligent. It's just there to demonstrate how to use it. We have a getter that returns a ushort. We have a setter only property that takes an unsigned long. We have a regular property that gets and sets an unsigned long. We have a Boolean method that takes an ushort and returns a bool. And we have a method, do not make your code unreadable, which I will show you now, then. And we have a void method. I've implemented the same interface twice. Once in the standard class. Basically, I have a private member that stores my number. The ushort getter returns hard-coded 42, as it should be. The setter just sets the number, and the regular property returns the number and sets the number. The Boolean method takes an input number and compares it to the getter. If the getter is identical, then it returns true, otherwise false. The void method writes out a string to the console and uses the nameof property, which I will show you in a second what that does. And the do not make your code unreadable method basically compares the number to the getter and then produces one result, and if they are not identical, it produces a different result. This method doesn't have actually any hidden meaning. It's just code I invented to use an if and two different results. And now to the expression-bodied function. We have the same private member, but now we have this ushort getter, and it simply, with the lambda expression for arrow, returns the 42. There is no get, there is no return. If we compare this to the other one, here we had the get and the return, which of course one could write on one line, but you still need the get and the return. With the expression-bodied function, you just have the result, and that's it. The setter cannot be used with an expression-bodied function because it only works with getter-only properties and methods that have a return value. You cannot use it on void methods, you cannot use it on getter and setter properties, and you cannot use it on setter properties. That's why the same implementation is here as it was in the standard class, because you cannot replace it in a property that has a setter. Now we have our Boolean method, and basically it still does the same as it did here. You have return number equals u.getter, and here in lambda notation you have the same result, and the return value will be a bool, which is implicit like when you use the where clause of the link implementation of lambda of link. I'm sorry. The void method does exactly the same as it did in the standard class, because you cannot use expression-bodied function without a return value. And now here's our initiative to make unreadable code. It's the same exact code as the standard implementation. It just makes use of the conditional operator, the short if, so to speak, and puts everything in one line. One might think this is cool, but in reality it's not. A, because the conditional operator does not allow parts to be debugged. I cannot, in a lambda function, I can create a breakpoint, and it will only evaluate this part and break here once it's called. In a conditional f, only the whole expression can be breakpointed. And also, this code is not really readable. This is one thing we have to learn. Write readable code for the next person, not for the compiler. This is just basically, oh, now I can make expression-bodied function. I need a one-liner for this. Okay, then I will use the conditional operator, so I can make one line out of it. But I want it to be clear, this is no better code than this. We live in the terabyte age. You don't have to press your code into one line. It doesn't make it better. So, and now we have the program. Basically what the program does, it has a variable of the interface. It first creates the standard class, executes a lot of these methods. Then it creates the expression-bodied function class and executes the same methods again. I will let it to run here. The output is 42, 23, 47, false, true, 12, 1664, hots and horts. And when the code comes to the expression-bodied function, I will now step into it. I've used again the using static here, so I can just write right line. What it does is basically just like a get, it gets into the property here and then outputs the 42 again. It sets the value just as usual. Now I call the Boolean method. It steps into this part and implicitly returns if number is equal to getter. In this case it's false, so it writes false. Now it compares 42 to 42, which in first guess would be true. Hey, it's true. And now it's executing the do not make your code unreadable, which you cannot further debug, but there is some sort of result at some point. And then the void method. And the result is exactly the same. It's just a different kind of syntax. Okay, now let me take a quick detour to the nameof property. The nameof construct was invented, I very much think so, for WPF, Windows Presentation Foundation, and view model, model view view model. As I'm sorry, model view view model. Because there you have a lot of operations with strings. I've opened a sample project to show you this if you're not familiar with WPF. In WPF, the UI is designed in XML. So you have basically an XML window that describes your UI. And here in the bottom, you have a lot of properties that are bound basically via reflection to your view model. And in your view model, you always, anytime you want to update the UI, you send a property changed event. And in this property changed event, you give the name of the property. And in earlier days, you had this property, which was bound to your UI. So in your XML or your XAML, you have this left file name property, and you have here this left file property. So the UI will get this property, and when you set it, you want to update the UI, say, hey, it's changed. And then you fire an event, this property changed event, and you say, hey, left file name has changed. But as you can see here, left file name is a string. And when at some point in the future I rename this property, and you don't have the advanced renaming tools, then this name remained untouched, and your UI was not properly updated. And that's what the name of property is for. And I'm always saying property, but I mean keyword. Basically, what this does is the moment I rename this variable, this will also get renamed. You can use this, for example, if you implement public interfaces and you check your parameters of your public interfaces and throw argument exceptions for wrong arguments, argument null exceptions when a variable should not be null but is null when your interface is called or your interface implementation is called. And then you can use this, because when you throw a new argument null exception, then you're supposed to put in there this param name. And now you can do that. Now you can say nameof, and in this case döner, and now you have a proper argument null exception, and it will output döner as the argument that was null. And if you look at this in the reflector, what's actually happened is this is not something that is evaluated at runtime. It's actually changed during compile time into a hard-coded string. Let me show you that quickly. Reflector. I would not yet open. There. C#6 expression-body function. It's both in the standard class and the other one. So basically what it did is, here's already the name HOTS in there, because HOTS was the name of the variable. So it basically replaced it already at compile time. This is not something that is done during runtime. And in the expression-bodied function, the void method, we have the name döner, because that's what I last wrote, and then compiled. So this can be very useful, especially in the Windows presentation format, Windows presentation foundation environment, but also, as I showed just now, for public implementation of public interfaces and so forth. So, the next one I'm going to talk about is the null-conditional operator. The null-conditional operator is intended to be used for variables who can be null and must be checked against null before using them. Usually you have an if statement. If my variable is not null, then call this property, call this method, or do some further checks. With the null conditional operator, you can call the member or the property or the function inside it without caring if it is null. Because if it's null, the code behind it is not executed, behind the operator is not executed. That's done in a simple way. If you expect a return value from such a function, the return value, if the function was supposed to return a reference type, a class of some kind, then it's an actual instance of that, or it's null. If one member of the chain of the null conditional operators is null, the result will be null. If the result of the method or property or was supposed to be a value type like an integer or bool, then the result of the entire statement will be a nullable of that value type, because if the chain breaks at some point, it has to be possible to return a null, and that's why any value type is turned into a nullable of that value type. So what I did I here? I created an interface iCar. My car has a cabin, and my cabin has a radio and a number of seats. And my radio has a property that the radio is on or off. It's a getter setter, so I can turn the radio on and off. I can select my favorite radio station, and I have an event in case some traffic info is aired and my radio wants to get louder, so I can listen to the traffic info. And my seat has basically just a color, and I used console color because this is a console application, it's just for demonstration. My radio is only implemented one. I only have one radio for all cars, which has a public property from the interface. And here it's something that was on the initial slide. This is an initializer for auto properties. Before this version, it was not possible to use this kind of syntax with a hidden field, a property with a hidden field, and initialize it at a declaration point. If you wanted to do this, you had to declare a constructor and then set is on to true. But now you can do it in one line. Although I have to admit, I'm not a fan of this syntax. I'm more of the school of actually initializing properties in the constructor if they have any value other than the default. So I personally never would actually use this. I would still write a public constructor, call it radio, as I should have, and then set it on if it should be on. But it is now possible to do this if you wish to do so, to just initialize this variable. And it's like any, if I were to create a field and initialize it at once, this would be initialized at the same time before the first constructor is called. Then I have my select favorite radio station, which checks if the radio is on. If it's not on, you cannot change the station. Then it's writing my favorite radio station here in the region, and tries to send in traffic signal. And the traffic signal, there's an interesting thing about the null conditional operator, which I'm going to show you now first. So I just create a sender. This is this instance of the class. I create an empty event args, and now I have three different ways to create to fire an event. The first one is to simply query the traffic info event if it has any subscribers. If it doesn't have any subscribers, then I do nothing. Otherwise, I send the traffic info signal. The problem with this kind of implementation is that it's not thread safe. That's not important for most applications, but you should know this is not thread safe, because when this is checked here, between here and here, can another thread could unsubscribe from this traffic info, and this would suddenly become null, and here then it would crash with a null reference exception. So this is not a good way to implement events, especially in a multi-threaded environment. The thread-safe variant that you would do is you put the traffic info, the current traffic info list or event handlers into a variable. Then you check that for null, and now you can fire the events for everyone who was subscribed this, in the instant that this variable was given the content. Because if after this point someone unsubscribed from traffic info, this has no impact on the handler. So now the handler is stable. So if it wasn't not null here, it will still not be null here. And this is the first time you can use the null conditional operator, because the null conditional operator is deliberately made thread safe. The internal implementation of the null conditional operator for events is basically exactly this. The one thing you cannot do is you cannot implicitly call the invoke method like it was done here and here. With the null conditional operator, you actually have to use the invoke method. And okay, copy paste error, or not completely following through with that. So now all three events are basically identical, and Visual Studio even offers you to reduce this to this new syntax, because they know it's thread safe. They know they don't accidentally make your code worse by using this kind of syntax. Okay, now let me show you my two implementations of the car. My first is my car in construction, and it's basically on the first ramp on the construction line, so it doesn't even have a cabin. Nothing. Doesn't have a cabin, then it's obviously it doesn't have any seats, it doesn't have a radio. And my completed car, it does have a new cabin, and when a cabin, because I was lazy, when a cabin is constructed, it automatically gets a radio, it automatically gets a driver's seat in red, it automatically gets a passenger seat in yellow. When asked for the radio, it returns the radio. When asked for the seats, it uses the yield return statement to first return the driver's seat, and after that the passenger seat. So now to the null conditional. First, let's talk about booleans, because this is important, especially for if statements. A nullable, if you didn't notice, there always have been for the basic for the core data types, there have always been the actual data type and a keyword. For example, most use the keyword bool for boolean, int for int32, long for int64, and so forth. So basically these four declarations are all the same data type. Nullable of boolean is the same as nullable of bool, is the same as boolean question mark, is the same as bool question mark. So I've now used 4 different variables, and I randomly assign values to them. My first is true, the second one is null, the third one is false, and the fourth one is null again. And I put them in this compare boolean method. which I used as a params array, so I could just put them in here without making any array out of it. If no params are given, I simply return, and otherwise I use a for each loop to iterate over these booleans. And here's the interesting thing: a nullable boolean is not a boolean. It's a tri-state object which is true, false, or not defined. And in an if statement, you can only use an actual boolean. When I uncomment this code, it will not compile. It will tell me it cannot implicitly convert a nullable boolean to a boolean. So if you have a nullable boolean, you cannot not use it in an if statement as you would use a regular boolean that is simply true or false. So this will not compile. What you have to do in this case, you have to actually compare it to true. It looks a bit weird, but it's just the way it is with nullables. And the, uh, the, the comparison that it's executed here is that anytime you compare a null to anything else that is not null, this will be false. Only if you compare a null to a null will be true. So item compared to true is false if item is null. If item is null and it's compared to false, it's still false. Only if item is null and it's compared to null, then it will be true. So with my 4 examples above here, only the first one is true, then it's null, then it's false, then it's null. So only this one will evaluate to actually true here. This is defined in the C# specification. I've linked to it here again. It's the same link as in the PowerPoint slides. And it's again explained in the Microsoft Developer Network documentation for the nullable data type. Now let me run this. As I said, these booleans are basically identical. That's why I can put them in a nullable boolean array. It's not null. And now for every one I will execute. The first one is the only one that's actually true. So it will write true. The next one is null, which makes this whole statement false, and it will not execute it. The third one was false, and false is not true. It will not be executed. And the fourth one is again null, so it will not be executed. Okay, the next thing is with lists, because that's where you could think there's a difference, but in actuality it's not. Let's take a look. I have a list of int32, basically a list of int. I do it the classic way to check it. So basically what I do is I ask, is the list not null? And does the list have more than 0 elements? And if it does, I output the first element of the list. Otherwise, I say it doesn't have any elements. Then I use the null-conditional operator to achieve the very same thing. And it basically shortens this statement, list is not null, and list count greater than 0, to list null-conditional operator count greater than 0. And now the interesting question is, why isn't that a simple boolean? Why is this suddenly becoming true or false, and the if will eat it, even if the null-conditional operator is used? Well, the reality is, I've showed it here. I've created a third method to show you how it actually works by simply using a help variable. So basically what list dot count does is return a nullable of int32. And if you compare this nullable int32 to 0, the same is true as the as was true for the boolean. Any comparison of null to any actual value will yield a false. only a comparison of null and null will yield a true. So it doesn't matter if you compare the count to greater than 0, equals 0, less than 0. If count is null, all of these will yield a false. Only if you were to compare count to null and count was null, then this would yield true. So let's run the code. Our list is null. So basically this returns false, so no elements. No elements. Null-conditional, no elements. Count is nullable, but it's null, so false, no elements. Okay, now back to our car. I again used an interface, so I can use a variable called car. Can first use my car's construction, which doesn't have a cabin, if you remember, and can process that car. And I can then use the completed car and use the same method again. So what I do in process car, I try to switch on my favorite station, and for this I ask car, do you have a cabin? And if you have a cabin, is there a radio and is the radio on? Now let me first make it perfectly clear, this is not good code, because you have too much coupling in here. You go to the car, you ask for its cabin, then you ask the cabin for its radio, and then you ask the radio if it's on. So basically, this program class now has accesses throughout basically my entire code of this program, and it's totally coupled, and that's not good code. But for the purpose of this example, I left it here so you can see. So basically, what happens here? The return value is a nullable boolean, because this is a boolean and it could be null in any of these stages. I didn't check the car for null because my car is never null, so I could leave that out. But the cabin could be null. The radio actually could not be null because my cabin, if a cabin is constructed, the radio is also constructed. But to show you how you can chain these together, I check if the cabin is not null, then it checks if the radio is not null, and if the radio is not null, then it checks if it's on. And again, you have a boolean, basically a boolean, you need to compare to true, but because this is not a boolean in this case, because the entire expression becomes a nullable boolean. And if it's actually on, then it selects my favorite radio station. Afterwards, it registers for traffic info. Again, selects my favorite radio station because, as you remember, I simply combined this code. So the moment he switches to my favorite station, by pure coincidence, the traffic info is running at that moment. And afterwards, I simply unregister for the event to properly have a register and unregister pair for any event. And if the radio traffic is coming, I have actually a jam on my favorite autobahn. Okay, let's run this code. I construct the car and take my car's construction. I try to switch my favorite radio station, but as the cabin is null, this entire statement becomes false and the code is not executed. Yeah, and I try to give me the colors of my seats. So I do the same thing. I ask the car for its cabin. This will return null, and then of course I don't get any seats in my enumerable seats. So seats is null because this is a value type. So of course this can be null, and I don't need a nullable reference type. So seats is null. So here doesn't happen anything, and my car is processed. Now I have fully functioning car. I try to switch on my favorite radio station, which means radio is on, because as you remember, the radio was turned on the second the radio was constructed with our implicit setting of the is on property. So, yay! I'm listening to my favorite radio station. So now I'm registering for traffic info. And I select my favorite radio station. And now I'm sending 3 times the event because of all 3 implementations, because I now have a registered listener to this event and the radio. And now I'm sending 3 times it basically tells me 3 times that I have a traffic jam. And now it tries to print the seats. It gets the enumerable, and as you can see, if you never worked with link or yield return, what it basically does is the seeds code was not executed at this moment. Let me go and take a step back, set next statement, and let me go to the implementation here. And let me set a breakpoint here. Now I step over it. He did not execute this code in here. He did not actually get an enumerable of seeds, because the yield return is basically it's called delayed execution. This code will only be executed if someone asks for an enumerator of this enumeration. So basically, if you use explicitly get enumerator, or implicitly if you start a for each loop, which I'm going to do now. My seeds is not null, and as you can see here, he has now an anonymous delegate to my seeds collection or enumeration. And now I print the seed colors. Now I start and for each on this enumeration, and as you will see in a second, now it returns the first value, but only now. But yield return is a topic for another video. Now it returns the first, and basically it prints the console color. It prints the word seed in the color of the seat. In this case, the driver seat was always red. The passenger seat will be yellow. Now it returns the second value, and now you can see here, now it's returning to my code to retrieve the passenger seat and retrieving the color and printing the seat in yellow. And that's basically the 2 primary features for the null-conditional operator. One is to ensure thread-safe event invoking, which makes this a cool one-liner. And the second one is to chain conditions together without having to write. The alternative to this would have been if car.cabin is not null and car.cabin.radio is not null and car.cabin.radio is on. This would basically, this and this are basically the same statement, only that this is much shorter and probably more readable. And if I've learned one thing from Uncle Bob, Robert C. Martin, it's that these kind of if statements should be more self-explanatory. His idea is basically that if an if statement is a little more complex than just comparing value A to B, you should make it its own method. Because in 2 years, if you have this statement here, you have probably forgotten what you were actually comparing, especially if there's a secondary condition on the radio or on the cabin that's not here. So what he proposes is basically to make this a method of its own and give it a speaking name so you remember what it actually compares or what the purpose of the if is. Because then in 2 years you can decide, is your new condition you just want to enter, is it part of the same logical if, or is it a new condition that just happens to take place on the same line of code? So you can either change the if method here and add your second condition, or you have to add another statement here, but outside of this semantic, because basically this means radio is on. If radio is on. For example, if I wanted to check additionally in 2 years that the driver's seat is indeed red, then I would now do this and car dot cabin dot seats dot using a link expression first, and then console color equals red. But this second condition has nothing to do with if the radio is on, so I wouldn't put it here in this particular code. And if you worry about performance and unnecessary methods, don't worry. I've seen it happening when you compile code in release build. This method will simply disappear again. It will of course be there for reflection, but if you for example have a crash somewhere, this method will not appear in the call stack. The compiler will simply remerge this code into this line. But you as a programmer have now a speaking name for what the actual purpose of this if statement is. And here, this is a prime example for a short expression-body function. I use braces because you don't need to you don't need to use bracelet. This is perfectly legal code, but personally I'm a fan of braces because thanks to the environment, if I use braces, it will tell me exactly where the statement starts and where the statements end. But now you have a short expression-bodied method that basically is only there to tell you if the radio is on. And now you can use it in other places of your code as well. And your if statement here is now perfectly clear what the purpose of the if is. If the radio is on. Okay, understood. Simple code. And then you do your other stuff. Okay, so much for expression-bodied function, yes, and the null-conditional operator. And the next one on our list is the null-coalescing operator, the question mark, because apparently Microsoft loves question marks. The purpose behind this operator is that if you have a method or a property that returns potentially a null, but you want to continue your code in a state where the result is never null, you can use the null-coalescing operator. But basically what it does is if the left side of the coalescing operator is null, then it will execute the right side of the operator, whatever that is in this case. And we have previously talked about the null-conditional operator, where the return value for reference type was an instance of this reference type, or null, and the return value for value types was nullable of that value type. With the null-coalescing operator, the return type for the reference type is still the reference type, but the return type for a nullable is the actual value type, because that's the whole purpose of the null-coalescing operator, that you do not get a null value when you use this operator. So the null-coalescing operator executed on a nullable value type will return you the actual value type. Okay, let me demonstrate you what that means. Let's return to our code, and I will leave that open for a second. If I now open the null coalescing operator, let me close everything so far as close about this, yes, and this as well. What I did here is I simply linked the very same files. So this cabin, this current construction is the very same file as above. The only thing different in this program is the actual program CS. And even there, I use the same main method. I create a current construction, I use a completed car, and I basically run the same code, only slightly different, and I will show you the differences now. So basically, I again use the process car, and I try again to print the car seats. I left out the whole radio station because this is not important here. So what does he do when he tries to print the car seats? Again, he uses the car, uses the null conditional operator to get the seats. And now potentially, as we've seen here, this is the null conditional code. The seats can potentially be null. What I did here is I simply asked if the seats are null, then this code will not be executed. With the null coalescing operator, I simply return, I chose to, in this case, I chose to return an empty enumerable of iSeed, which means that this seeds variable is always initialized. Either he actually gets seeds from my car, or he uses the empty statement, which basically is an empty collection of seeds. And then I can go and print my seed colors, go to implementation, and I can just use the for each seed, because this variable is now never null. I can always be sure that this is not null, and then I do the very same thing I did before. I change the color of the console, print the word seed, and then I reset the foreground color of the console again. Let me quickly execute this. Sorry, still wrong start project. And here we go again. My new current construction. Try print seeds. Seeds is null, so that's why I get an empty enumerable of seeds. And now if I run here this seeds, it will just stop short of the actual for each, because there is no seed. Okay, and the second thing I did was I decided that if my car doesn't have seed, there's at least one seed and it's gray. Doesn't make sense, but it's just for showing you the code. So I'm basically using the first or default from the link toolset code, which means for the nullable a reference type, the return value is null. And now I get the seed color, which, because the seed can be null, I use the null conditional operator, which means I get a nullable console color. And if the console color is actually null, then I return gray. And at this stage, I actually get only the value type. this operator will turn my nullable into an actual data type of this type. And now I can print the word gray because I always have a defined color. This is a value type. It cannot be null, and it prints the word gray. I used 3 lines here again for readability. I first got my seat from my car, or I didn't. Then I tried to get the color from the seat, and in the end I made sure that even if I don't have a color, I at least get the color gray. And in the initiative unreadable code, I could have pulled this all in one single line. Here's the first default. The return value is simply used with the implicitly used with the null-conditional operator, and if that's still null, then I use the null-coalescing operator and I get my seed color. But again, this is not good readable code. You shouldn't do something like that. It gives you no points. There's no points for writing such code. This is the same code, and the compiler will optimize the heck out of it, and it's far easier to read than this one-liner with the many question marks and implicit return values and so forth. Okay, and now we have our actual car. Now the seats, again as previously, returns this a function pointer to the implicit yield return method. So this it will not evaluate the empty. So I still have the function pointer. I can start my for each. It will again go into the yield return method. Will print my 2 seeds colors, red and yellow. And there's my red and yellow. And now it will try to get my my first seed, which is the driver seed, again in the method. And I have my driver seed, and that's not null. So the null-coalescing operator will not take place, and my seed color will still be red. And there's my red seed. And that's how you use all these different operators. And now to show you that you can put them all in one line, you can use the nullable data type, an int question mark. That's the variable's answer. And if it's towel day, then it will try to get the answer from a calculator, which may or may not be null. If the calculator is indeed null, the answer is 42, as it should be. And if it's not towel day, the answer is still 42. And of course, the implementation of my calculator, if it's actually used, will also give you the answer 42. Here's my program, constant of 42, of course. Then I use the nameof again. 2 times I will actually insert a calculator that it's null. Towel day is in the first case is true. In the second case, it's not towel day. And the third case, it is towel day, and it's you have a towel calculator. And the fourth case, it's not towel day, and you have a towel calculator. And basically, the towel calculator refers to this interface, and the interface has a method that gives you an answer, which is int32. And there are 2 implementations. The first one is again expression-bodied. It returns 42. And I also have hidden a Star Trek calculator, and in Star Trek the answer is not 42. The answer is actually 47. And there's actually one case where there will be a 47. Now let's run it again. Wrong program, I'm sorry. So first case is it is towel day, but our towel calculator is null. So We have now an expression-bodied function with the conditional operator. Towel day is true, but the calculator is null. So the answer of this statement is null, because this is null, this is null, so the whole term will be null, because this is what's executed, because towel day is true, so this part of the conditional operator is executed. So now we have a nullable answer, which is null, and if the nullable answer is null, then we use the coalescing operator to return to the default of 42 and print the answer, and our answer is 42. Surprise, surprise. Now I can use the get nullable answer again with it's the same method. It returns null, and I use the coalescing operator, and now I get an actual data. What was before a nullable data type is with the coalescing operator a simple value type. It's also described in the C# specification and in the program examples for the nullable data type, as you can see here. And it's printing again 42. The calculator is now null, which means the coalescing operator is executed, and now it returns the Star Trek calculator. Star Trek calculator means it's towel day, the calculator gives an answer, and the answer is 47, not 42, and it prints 42. And now it iterates all others, false and null, true and towel calculator, false and towel calculator, and the rest of the answers will simply be 42. Always 42, except in one small exception. Yeah. And the last thing I want to talk about, which has nothing to do with Microsoft directly or C#, but which I think is a very good add-on for Visual Studio, is the LetMeEdit add-on. And basically, I can tell you what I usually do. I often edit project files of .NET directly. So I have to, in Visual Studio, I have the choice to load my project file in a third-party editor like Notepad++, or I have to unload this project. Now I can edit, and now I can directly edit some properties or something else here in this file. But that's tiresome because now the project is unloaded. I cannot compile it. I cannot check if my changes I made here are actually correct or if I accidentally destroyed the file. I have to reload it and see what happens. The add-on LetMeEdit, which you get via this Visual Studio Gallery URL, adds another entry in the context menu of the project, and it's called Edit Project File. And what it does is basically it copies the project file to a temp location. In my case, it's dtemp. Calls the file exactly as the project plus .xml, and then you can edit it there. What it additionally does is it has a file system watcher on this file. So the second I save this file, the add-on takes this file and replaces the original project file, which then Visual Studio immediately notices and says me, yeah, my project file has changed. So now I can say reload, and my project is again there. For example, if I now remove the Star Trek calculator from the equation, I've changed the project file, my Star Trek calculator is gone. My project can no longer compile because I have a reference in the code to the Star Trek calculator, and it now has no clue what a Star Trek calculator is. So I realized my mistake and say, sorry, I didn't need that file. I store it again, and if you look here, you will see the Star Trek calculator reappear again the second I press reload. There it is. And now I can compile my code again. Okay, that's it for today. I hope you enjoyed it. I hope you understood what I was explaining. I'm sorry for the many speaking errors I made. Um, I try to get better in the future, and I wish you a nice day. Bye.